Hello, welcome to the machine learning at home. Today I will discuss how to make key-means clustering in a situation when you have characters both numerical and characters with categorical meaning. So for example, you have numbers like 1, 2, 3 and also maybe colors like red, green, blue. So how to clusterize this data if you want a key-means clustering? So just to remind you that key-means clustering is a way to clusterize dataset in one flat set of clusters. So every observation should belong to one or another cluster. Very widespread and typical way of clusterization. So there are several approaches, and one of them is approach with our package clusmix_type. So first of all, we should load the library clusmix_type. So be careful, it's kind of like M and T are in uppercase. Okay, in my case everything went well, but if you do not have that absence of answer on your command, you must install the package. Like type something like install packages and then clusmix_type. Remember, it should be in quotes. And I don't do it because actually it's already installed on my computer, but you might do this command. So in my case everything is done, and you might install it and then run the same library clusmix_type. Then you can go with a data set which contain mixing of characters. So we can make it artificially. So let us operate with the same iris data, and I will modify it slightly. I make an iris new data set out of iris. So we'll make it like iris first 3 columns. Just to remind you that this data consists of 5 columns, 4 numerical and 1 column contains species names. Well, it's kind of cheating to use species names columns, so what I will do, I will retain first 3 columns, and then I split column number 4 in several categorical factor characters, so simply by order of numbers. You will see how it's done. So I will need a cbind to make them together, and then the last column will be made with a cut command. So cut will split this last column into intervals, and each interval will become one of level of the factor character. So iris column number 4 will be split, for example, in 3 intervals, and then everything together will be put into iris.new data. Okay, just to make an idea what's going on, we need to look on a data set. For example, with the command head. Then iris new. And as you see now, the first 3 characters are from initial iris dataset. The character number 4 contains something strange. These are intervals. So cut command splitted column number 4 of original iris data into 3 intervals, and you can see names of these intervals. And we can also run str, which will show that last column is a factor of 3 levels. So this is actually categorical characters split in 3 factor levels. So this is important to remember. Normal key-means will not deal with this type of data. It wants only numerical part. So how to work? And this clusmix_type, which you already loaded, can deal with it with the command Keyproto. So this is a command. This command is similar to key-means. So you need to put the data as a first argument, iris.new. Then you must say how many clusters do you want. Actually, all key-means want this information. So key equal to 3. And then Also for stability, because what I found myself that Keyproto is not very stable sometimes. So for stability, I would increase number of starts. So to make it started several times, you will see 3 different outputs, because I will say n start equal to 3. And then, of course, we need to write down the result of this command in some new object. For example, iris key p. Okay, everything is done and we can go. As you see, 3 times it outputted something. So this is not very important at the moment. What is most important, that iris key p contain now the clusterization, exactly what we need. So it accepted the factor of 3 levels, which normal key means will not accept, and will perform clusterization and put every observation into some particular cluster. So let me show how it went. Then I will need my own package. And this package I need for my misclass command, which has an ability to compare clusters even in case when names are not correspond with each other. So I can simply say misclass iris key p, and then I need part of this key p which contains cluster, this one, cluster. Then I will need actual initial species distribution, that was a column number 5, which we totally ignored in our work. So iris species or column number 5. And then I will also need to specify that the command, the program should find the best corresponding cluster, because names are not corresponding. Best equal to true. Okay. And as you see, clusterization went very well. So I'm kind of impressed. Even when we split the character number 4 and then we actually lost information, definitely. So now instead of numbers, we have 3 factor levels. So lots of information was lost. We still have good splitting, so it's very low percent of misclassification. Only like 8 Virginica were put in the wrong group, no Setosa, only 2 versicolor. Everything went quite well. Okay, but what is alternative way? Alternative and more classic way is to use Governor distance. Governor distance is a way of calculating distance of all types of possible characters. So for example, we can use factors, we can use numbers, we can even use logical characters for Governor distance. And we can use Governor distance together with PAM, with PAM clustering from the other package. So let us load this other package first. It must go with R, so it always on your computer. Library cluster. Okay, and then we need to calculate this Governor distance and apply it to PAM clustering. So it looks like a bit complicated, but actually the process is very similar to what we just did with Keyproto command. So we simply say, instead of Keyproto, we say PAM. Instead of keyp object, we say PAM again to separate them from each other. And we need to insert here the Governor dist command. This is from my package. Actually, cluster also contains Governor distance, but I prefer my own command because I know how it's behaved. And PAM needs number of clusters, but you can ignore number of starts because PAM is pretty stable. So this is how our new command will look. And what I will like, I like to compare results of PAM with what we just said, like a 3.3% of misclassification, right? Okay, let us do it. Okay, fast again, and then we need to do very similar thing. So make misclass of PAM iris PAM, and then just to make sure that everything is named. Okay, so clustering, and this is a part, a slightly different name. Clustering iris species and best is true. So actually very similar, but not exactly the same. That's the worst thing in R packages. The commands are sometimes named in a slightly different way. Okay, this is interesting. You can see that it's slightly lower. I mean, the quality of clusterization is only like a 0.7% lower. So almost the same, I would say, taking into account as well lots of random factors, and our splitting is not perfect probably. So we can say that results of Keyproto command and of PAM command on gather distance are very similar to each other, almost the same. As you see here, 10 Virginica were put in the wrong group, and whereas only 8 were put in the wrong group in the previous case, and 2 versicolors were put in the wrong group versus 2 versicolors, same number in the previous case. So as you see, this cluster mix type and way with gather distance are essentially similar, and you can use both of them in case if you need key means clustering on data set which contains not only numerical but some other characters. So a really important workaround in case if your data is, like they say, of mixed type. Okay, thank you very much. This is it for today.